Hello everybody, we're getting ready to do lesson 16.2 of grade 6 math today. And 16.2 is about mean absolute deviation. And you got 62 points on your classwork sheet, and you have 2 points on your notebook guide or your notebook. Students, put your name, date, period here. Due date here for onliners and homeschoolers. And let's go right into today's bell work. Teachers and students, find the quotient, write the remainder as a decimal for this one, students, and then for this one down here, write your remainder as a decimal. And teachers, give your students about 3-4 minutes for this. See you in 3 or 4 minutes. Okay, welcome back everybody for today's solutions. We have 91 here divided by 52, so you should have gotten 1.75 here using long division, or depending upon your class, you could use a calculator for that. And then down here, you got 57 divided by 24, and for this one, you should have gotten 2.375. So this is written as a decimal here as well. Into today's lesson in our first notebook entry here, essential question. How can you determine and use the mean absolute deviation of a set of data points? So that is our essential question of today's lesson. And then our explore activity will involve understanding mean absolute deviation. So we're going to get into mean absolute deviation, or MAD, M-A-D, MAD. And first of all, we're going to start with a notebook entry here. A measure of variability is a single number used to describe the spread of a data set. It can also be called a measure of spread. One measure of variability is the mean absolute deviation, or MAD, M-A-D, which is the mean of the distances between the data values and the mean of the data set. So there's a lot there. Is the mean of the distances between data values and the mean of the data set. So we have means of means here, lots of means going on. So to start this out, we're going to start off here with a question, a problem. The data The data represent the height in feet of various buildings. Find the mean absolute deviation of each data set. So, okay. So A here, we have a mean here, 60, 58, 54, 56, 63, 65, 62, 59, 56, and 58. So this is a set of data for various buildings. These are heights. So we need to calculate the mean of this set here. How do we do that, students? So to do that, we get a divide through by 10, because how many values have we got here? We got 10 entries here of data. And then when you add all of these together and you divide by 10, when you add all these together and divide by 10, you will get a mean here. So round to the nearest whole number of this mean up here. What do we end up with? So for that, we get 59. So these values up here, rounding to the nearest whole number, will be about 590. And you divide that by 10 and you end up with 59. So the mean would be right here is your mean, actually, of all these heights of buildings. Complete the table. So now we're going to get a table here. We got height. Here's our heights again. Down here is 60, 58, 54, 56, 63, 65, 62, 59, 56, and 58. And then the distance from the mean. Here's our mean here. So how far is 60 away from the mean? So this is 1 away. 58 is 1 away. 54 is 5 away. 56 is 3 away. 63 is 4 away from the mean, which is 59. 65 is 6 away from the mean. 62 is 3 away. 59 is right on the mean, and then 56 is 3 away from the mean, and 58 is 1 away. So here are all of our distances from the mean. So what do we do with the distance from? Once we figure that out, calculate the MAD by finding the mean of the values in the second row. So we need to find the mean of the mean. So to do that of the table, so the second row of the table, round to the nearest whole number, and then when we do that, again, what we have our distances from the mean. We add all these together, divide again by 10, we end up with 3. So the mean of the mean, or the mean of the distances from the mean, is actually 3. This is our number here from distances from the mean. So to find the mean absolute deviation for B, for this we got a different data set here. We found the mean of the previous. Here's our second set here. Find the mean absolute deviation of this data set here. 46, 47, 56, 48, 46, 52, 57, 52, and 40. So to find those, what do? Find the mean. So to find the mean, we're going to add, round to the nearest whole number. So we're going to add all those data values together, divide through by 9, so we have 9 values here. And then when you add all these up together, divided by 9, we get 50. So here's our mean of those data values. That's the mean of the data set for B. So complete the table. So now we have another table here. Height, again, 46, 47, 56, 48, 46, 52, 57, 52, and 45. And then the distance from the mean. How far is 46 from 50? Calculate the MAD, round to the nearest whole number. So 46 is 4 away from 50. 47 is 3 away. 56 is 6 away. 48 is 2 away. 46 is 4 away. 52 is 2 away. 57 is 7 away. 52 is 2 away. And then 45 is 5 away. So the mean of the distance from the mean would be 4. So our mean of distances from 50 would be 4. That would be our value for the distance of the mean, from the mean. Okay, so that's how we do our MAD. So reflect a little bit on what we just did. 1, analyzing relationships. Compare the MADs. How do the MADs describe the distribution of the heights in each group? Meaning, how does the mean describe how spread out our values are from the mean? So students, teachers, give your students about 2 or 3 minutes to compare the MADs and describe using full sentences here. Describe that. Okay, the MAD in part B is greater. The heights in part B are spread out more from the mean than the heights in part A. Okay, so knowing now how to find a MAD using mean absolute deviation, the mean absolute deviation can be used to answer statistical questions like in the blank here, students. So the idea here is in the real world. Many of these questions may have implications for the operation of various businesses. So with a data set, you can use a data set and also the knowledge of a mean absolute deviation to make business decisions, okay? So for example, excuse me, a chicken farmer wants her chickens to all have about the same weight. She is trying 2 types of feed to see which type produces the best results. So all the chickens in pen A are fed premium growth feed, and all the chickens in pen B are fed maximum growth feed. The farmer records the weights of the chickens in each pen in the tables below. which chicken feed produces less variability in weight? So we have pin A, and then here are weights for pin A, and then pin B, here are all our weights in pin B. So which kind of feed should this farmer choose to have less variability in her chicken weight? What do we do? To find that out, we go step 1 here. Find the mean weight of the chickens in each pen. Round your answers to the nearest 10. So pen A, we have these weights here that we add together. And we divide through by 10. And then our mean for that would be about 6.3. So this would be our mean for pen A. And then for pen B, we add our weights here. Add all these together, divide by 10, and then we come up with a mean here of 6.7. So we have pen B at 6.7, 6.3 for pen A. And we'll get back in that part 2. That is part 1 of 16.2, grade 6 math, animated PowerPoint math video at AOL.com for questions or course materials. Thank you very much.